Hello everyone. So in our last video we have studied about the streaming concept in Java. Stream concepts in Java. Okay. So let's revise what we actually studied there. We understand what is stream, what is its definition, difference between stream versus collection. Fourth, we studied about the internal versus external loops, external iterations. Fifth, we studied about the intermediate and terminal operations. And sixth, we studied that the stream is only traverse once. Right. So these are the things, concepts we learned in the last video. And today we will study it about the operations. So all those operations that we have discussed here, about these operations we will discuss today. Cool. So in our today lectures, we will mostly talk about the intermediate operations. And in our next video, we will study about the terminal operations. Cool. So let's start one by one. First, we will study about the filtering. So this is filtering, and now filtering has different concept. First is the filtering with predicate. So how filtering with predicate works? Let's start taking an example. So let's suppose we have certain dishes, and these dishes are, let's say, some food items, means there are dishes. So there are a certain set of dishes. Now we want to filter out all the vegetarian dishes out of them. So for vegetarian, let's say select the green color. So some of dishes of out of them are the green. This is green. This is green. Let's say this is green. So next we will filter it, something out of it, means we will selecting this, and this, and this. This is using the filtration operation. Let's see how exactly you are going to write the code for the same. So I have already created a dish inventory. So there are a certain set of dishes, and this has the three properties. It is the name, is it vegetarian or non-vegetarian, and then it has certain calories. Now moving to that, I have created certain dishes, let's say cornflakes, noodle, pasta, chicken, tuna, river, butter fish, and the apple. And there is their vegetarian or not, and their calories. Sorry, apple is being marked as false as the vegetarian, but it is now I'm correcting it as true. Cool. Now for in the main methods, we got all the dishes from the inventory. Now we want to get the dishes which are vegetarian in nature. So we want all collect all those lists. Right? We keep on doing it with the streams. So initially we had dishes, convert them into the streams, then perform the filter operations. How you perform the filter operations, you will perform on the dish, and if it is a vegetarian dish, cool, and then collect those dishes, collect to list. Finally you have all the dishes that are being vegetarians, and I hope this has the toString. Let's say at the rate toString method, we will add the toString method. So generally you have to write the toString methods, but I'm using the Lombok extensions using which these methods are being auto generated. And let's say I'm moving again to back to the main methods. So store the results into this, or this is a vegetarian veg dishes. Now I will just do what I will do. I will just print all those. This is system dot out dot println, and then print the wedge dishes. So I'm just running these applications. It will should print all the vegetarian dishes. So here you can see the cornflakes, noodles, pasta, and the apples are these are the dishes being printed, and these are the vegetarian dishes. But behind the scene, what exactly has happened? So we have seen it with the diagram, but let's say we want to understand it better. So initially, you had certain menu, you had the certain dishes, whatever is in our inventory. You see, it is a mix of vegetarian as well as the non-vegetarian dishes. Then we use the filter method, and that particular filter methods filter out some of the dishes which are only the vegetarian in nature. Then we collected it to the list. So that's what exactly we have done using the filter method. So how filter method actually works, right? So here we see that our filter methods, it accepts certain predicate, it takes certain predicate and returns you back the streams, and the predicate has a particular method. So let's say implementation of predicate as well, and predicate has this particular test method. Based on that, you will validate your conditions. If the particular conditions is being satisfied, it returns true, otherwise the false, and we will filter out the results with the true conditions. Right, so here we have seen that the method we have passed in the predicate is vegetarian. It means if it is vegetarian, it will return true, otherwise it will return the false, and whatever the true, the filter method, it will filter out those into the next output stream. And then those are collected into the final list, and that is you will get in your vegetarian dishes. That's great. I think that's quite clear. Now moving to the filter unique elements. Interesting. I can do the example with the disease, but let's say we want it with some other example here. And let's say we have arrays dot as list. I'm adding certain numbers here: 1, 2, 1, 3, 3, 2, and 4. Let's say 5 and 5. So you have a array of numbers, and then I'm storing it in a list. This is list of integer. These are the beings numbers beings you have. Now what we want to exactly do, we want to, let's say, perform certain operations. We want to perform only the even numbers and unique even number. I think there is even numbers are mostly unique. So let me add here the 2, 4, and 4. So there are multiple 4s, but we only want the unique elements out of it. Unique even numbers. Let's do it. Then you have numbers, then you have numbers as the streams, then you want to do the certain operations on it, that is the filter. In a filter you will get a number. Let's say n is, you represent number with n, percentage by divided by 2. If remainder is 0, it means the number is even. And you want such distinct numbers, and then you want to not collect the same. Not sure if it is formatted in the correct manner, but let's say there is a format button, but I refactor. Is it formatting change? Okay, currently I don't see, but there is a control F command generally we use, but it is not working. Let's say okay, it's okay, and then we'll store that results into some final result list of integer even numbers we are getting, and we want to print it. So what should be the output? We should get only the 2, and I think for the 4 is the output only one time. So system dot out dot println, then and you print the even numbers. Cool. Let's run our code again. Run, and here you see it printed 2 and the 4. Got it. Okay, and I'm printing the vertices even after that. So this is just misinterpretation. I think let's complete it here, rerun it. So meanwhile it is running, you can also do one more thing here. So we can put the 2, 4, we can see in the output. But you don't even need to store it in certain variables. You can do it without this. And here you can have the for each and consumer here. You can do the system dot out colon println. Right. And this time if you run this particular code again, you almost will get exactly the same output, 2 and the 4, but it is printing in the every next line. Cool. Now you got it. Let's say see it with the diagram representations. So you had certain set of the numbers. I added much more than this. And then we have a filtering criteria. Filtering criteria, you pass a predicated lambda expressions based on the conditions is being satisfied. Those numbers are being included. So condition is include the even number. With here the 2, 2, and the 4. You see these numbers are repeated, but now you run the distinct operations. So only first two, if it is there, it don't add the second two, and then they get the 4. So you get the distinct. Then we had the for each and printed all those elements. I hope the filtering operations so far is clear to you. Now moving back to again to our whiteboard or the coding problem. We will understand another concept. So another concept is slicing of the stream. So what exactly you means by the slicing of the stream? Okay. So for example, we have certain dishes that we have talked about there. Okay. Let's say our dishes are being sorted by their calorie values. C1, C2, and better I take another color because it will seems that everything is vegetarian because we just discussed that particular example. So let's say I'm taking the black color and for us now it is everything is dishes. Everything is this. And these are being sorted by their, for example, calorie values. Okay. Now these are being sorted and now whatever I want is or somewhere here is the let's say 320 all elements less than the calorie 320. So if I apply this operation on the streams, it will check it is less than 320. So if directly you're using the stream, right? If it is less than 320, you say yes, no, yes, no, nee. Oh, sorry, it is since it is sorted, it is all yes, right? And then it will keep check. It will say no, 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 and no. So now whatever below it is everything is sorted in the 320 calorie, but still we are comparing it the streams till the end. Stream can be defined, we keeps on going. But if we use the slicing operations, for example, let's say take while calorie is less than 320. So what it does, it will take it, and as soon as it found the grid, it only does the short circuiting. So last time also we discussed this concept that short circuiting, it means it won't process the elements beyond a particular comparison or the values. So it won't be don't go beyond that, right? So another thing is if we want instead of that, we can also perform a drop while operations where calorie is 320. So what it actually does, it drop this particular element when we discuss the drop the first element, drop second, drop third, drop the one is soon found the element greater than this, it don't process it, it exactly returns you that particular result. So it again does the some kind of the short circuit, does the circuiting. So yeah, we understand the concept now. Now let's start with an example here. Or before that, let's sort our dishes. first and then we'll use the, okay. Here the sorted, this is, now I don't want to do the filter, instead I want to do the sorted. This is it is how I want to sort it. Integer dot compare dot d dot get calorie. But for the comparison, there should be two values, d1 and the d2. Right, then d1 dot get calorie and d2 dot get calories. This is the comparison you are doing, and it can be done written in a better way, comparing in compared road compare intent than this. Cool. Now you got the sorted disease, and then we want to apply the take while or drop while operator. But before applying that, let's take what are the our calorie values in the inventories. So generally 70, 40, 100, 110, let's say 150 we can take, 140 we can take a number. Okay, sorted disease dot stream dot take while, where our disease get calorie is less than approximately 140. Here list of disease and disease with low calorie. Rum dot r dot println disease with low calories, and then let's print out all those values. System dot r dot println, and then we are printing disease with low calories. Let's run our code again. What it is the output. Cool. Your apple, your tuna, and the pasta, these are generally having the less calories. But here again we want to do with the less this is with high calorie, but instead of using the take while, we want to use the drop while operator. Sorted this is dot stream dot drop while and the predicate. So we will use exactly the same predicate, means it drops those values from the streams and then the collect. Cool. And now print your system dot just with high calories, and here the this is with high calories. So with high calories, and let's print these values. So you get it has 20 and it has 370. So these two has the high calorie values. So far, so good. Let's remove these things. Now moving to the another section, that is the truncating. What truncation means? Truncation means take the values, how many are being required, and then drop the values after that. For example, you have these x, x, x. So these are the different, not just different numbers. So you said that take something out of it. So it takes those values and drop the another value. So there are two different operators in case of the truncating. First is limit and second is the skip. So in case of the limit, you specify limit 5. So it means take, let's change the color. Hmm. So it means take the first 5 and drop the rest. In case of the skip, drop the first and take the remaining. So these are the things. Let's understand it better with the another diagram. So let's moving it again on our page. And here, for example, you have different dishes then you do certain filters, you find the three. Let's in this example you have only the three, but let's say there are the more than three. In case limit three says that take first three, if you say the limit one, take only the one, and then you're doing the collect. In case of the skip means, for examples, you get the some results and you say that skip two means skip first two elements and take the remaining and then collect them to the list. Cool. You want the name of, we want to write the code. So let's say we want to name of the disease and skipping, let's say first limiting the first three elements. So here this is dot stream done dot, here I want, let's say I want to do the certain transformations. I'm coming to the how it is being implemented. Let's say this, but I want only, yeah, oh, okay, this colon colon get name, and then I want the limit. Let's say only the first two diseases I want, and then I want to collect them to the list. Instead of list, we can do the only the for each here without colon colon println. So it means we are printing the name of the first two diseases. Cornflakes and noodles. यहाँ पे let me limit disease. Now we want to do the skip operation. So again, we can copy that exactly the same methods, and we want to understand what happens in case of the skip. We want to skip the, instead of limit, we are using the skip, and it just skip the two dices. Then it. So here the skip dices. First skip is cornflakes and noodles. It skipped, and then pasta, chicken, tuna, and apples. It get all those in your output. Cool. So far we have understand three different concepts. So first we understand about the filtering. Second is slicing, and third is the truncating. Now moving to the next operations. So next operations in case of stream is mapping. So we want to transform one element to the another element. We have already seen the example of it, but let me again tell you how exactly the map works. So during the map, you transform one values to another values. So we will directly see it with the code example. And here we want to map values. First, we will do it with the disease. Then let's say system.out.println map working. Here, what exactly we are doing? We are taking the disease, then stream. Then we want to use the map. In case of the map, you want to use this, your this object, and you want to transform it into, so you can write the code like this, lambda expression and d dot get name, and this whole lambda expression can be transformed into this colon colon get name, so it can be rewritten like this. So it means your this object will be turned into a string that is the name of the disk, and then we want to do the just for each, I want to print all the names. So system dot out dot colon colon print. So we have printed all the disk names यहाँ पे map working. So probably this is little bit confusing now. So I will try to add these three hashes that will actually work like separator. So here These are the different diseases we have. But another thing, let's say you have your own list. You have some arrays dot as list, and list has certain string as a second is the hello, let's say world. So you have, let's say, this list, and here this is the list of strings. Something as I have taken it a variable name, then as dot stream. And what we exactly want to do, we want to get the output in the length of these strings. So string colon colon, and this is the length. So it will give the length of all these things, and we just want to print it. I don't want to collect them into first list and then printing that list. I directly want to put int here, and then for each what we are doing, system dot out has a function named println. It will automatically print, and then here we will put the suffix. Let's say use the map working prefix. So here we have printed the length of it. This is the 4, again this is 5, 5, 5. Cool. So it means now we understand how exactly our map is being working. There is another flat map concept as well, but I think it is slightly complex. I just give the little overview how exactly the flat map works, but I won't go in the details because I will cover that in more details in the futures when you understand all these concepts in easily. So for example, in case of the map, so you have a list of elements x, y, and z, and there's another array that has a, b, and the c, and let's say it is the x, and outside there is an array, and that can be converted into stream. Whenever you iterate or the stream, you receives all those objects, a object 1 and the object 2, and over that or you can perform some operations, but you want in the x, y, z, a, b, this output you want. Right? So what you have to do, you have to use the flat map. What flat map actually does, whatever the internal, it opens them and give the stream of those as well. So it gives you the stream of x, y, z, a, b, and the x. So after the flat map you get the stream of this. Over that you can perform the distinct operations, so you will finally result into this. Cool. So I hope you understand the concept so far. Oh, I'm writing here another things we have covered is the flat map. Now we are doing the most interesting operations. Now is like the finding and matching. These are the most used operations. Find and match. Okay. First, you have a stream. So for example, we have a stream, and the stream has x, y, z, a, x, y, and z. Okay. So there are the multiple operations. First operations you can perform is a any match. What exactly any match is working is it start matching. If any one of these match, it means a match is found. So it means it will short circuit if anything is being found. So let's write the code for this. So system dot out dot println, and here we are doing hash 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 find and match, and then hash hash food items. Yeah, what is our disease dot stream dot find any, yeah, any match, and then here are the conditions. this dot is vegetarian. ओके, अगर कोई भी एक एलिमेंट ऐसा मिलता है जो कि रिप्रेजेंट करता है कि इसके अंदर वेजिटेरियन फूड है, so conditions will be satisfied and then you can use it in the if condition, and then you can perform whatever the operations you want to do. None match. So okay, I'm just writing the syntax here. So first is any match. It means this is dot stream dot any match, any one of these match, and here this dot is vegetarian. Cool. Another is this is dot stream dot none match is means this dot is vegetarian. What are the conditions we have? But here the idea is it identified that none is matching. Then it is only returning the true. It means it has to check the complete list. Now next is all match. This is dot stream dot all match this dot colony is vegetarian. So it means it check if all the dishes are being vegetarians. Cool. And then we have used the find. So mostly we are discussing about the match and the find. So I think that's the good thing that we can discuss here. So you need to study about the match and there is another find. Whenever you say about the match, it means asking the question, does element E exist in stream S? ठीक है? Whenever we search about the find, give me E in the return when condition C satisfies in S. So now you understand what is the core difference between the match and the find. Match we have discussed about the different functions, and now we can talk about the find as well. So find any. What does arbitrary element in the current string? So let's say go in again your code and you want to use this is dot stream dot find any. It means what it returns, it returns any element in the stream. This is dot stream dot find first. It returns the first element that is matching into the stream. And now where is the conditions? So we talk about in our definition is the conditions. So here you want to this is dot stream dot you use the filter, based on the filter you this is let's say is vegetarian, and dot find means any this is exist which is the vegetarian in the food. So give that element back to me, give any element out of them back to me. Now you can find the first element, all those things you can do. Now another concepts that we can cover here is the reducing. reducing Reducing is kind of a terminal operations you can perform. And for example, we have previously used the collect, which collect all the elements in a particular list. It is kind of you had reducing the list. You can do the sum of these elements. You can multiply all those aggregation kind of operations you can do. So these comes under the reducing. Let's start with an example. So first I will write here system.out.println and we are doing here the reducing. Cool. So what exactly we want to do here? For example, if I have to do the sum of an array, how generally I write the code? So I have a list of numbers in sum is equal to 0, then for loop int num in numbers, whatever numbers we have somewhere it is declared about, so it's not giving the error, plus equal to num and finally return that particular sum. So that generally we used to do the sum, but now with using the reduced we can do the better. Let's say I have a numbers dot stream dot reduced, and here I can perform the operation. First, what is the initial value, and then I have to give an expressions what exactly I want, how I want to do the reducing. So here in this case I want to do the sum operations, reducing initial value and then the lambda expressions taking any two values, how that particular operations will be performed. Let's again see it in our chart here. Probably I have not included here the summations. It probably isn't it in screenshot. Yeah, it is in the screenshot that I have taken, but it is not being added. Let me add. Cool. So here we initially have the 4 value initial 0, take this particular 4, add it to the 0, final the 4, this is stored in the A, what this is you will get in the B, keep on adding and finally you will get a result. That is how it is operations being got reduced. Cool. Definitely you can do any number of the things here. You can find the maximum, you can find the minimum. Even you can reduce the operation without an initial values as well. So numbers dot stream dot reduced, and here let's say I want the integer colon colon max. This will return the maximum value in all those numbers. Similarly, you can perform the minimum operations and all those things you can do. It means your initial operate what, so you have seen in this particular we have given the initial value and here we don't have the initial values. So the first value of your stream will be considered as the initial value in this particular scenario. Okay. So we have so far discussed, I think, almost everything. I hope you liked the video. Thank you.